Southwest Mock 2026, E-Science, Paper 1, Intermediate Level. This question says, which of the graphs in the figure 2 best represents uniformly accelerated motion for a car on a level road? So let's quickly look at these four graphs, A, B, C, and D. We're supposed to choose one of them. So first of all, what is uniformly accelerated motion? This is the kind of motion where velocity is changing at a constant rate. In uniformly accelerated motion, the acceleration is not changing. All through the motion, the acceleration is the same. So let's look at the first graph. In the first graph, we have a straight line. Since we are supposed to determine the kind of acceleration from this graph, it must mean that the graphs are all velocity time graphs. So I could add velocity and time here if I was to analyze these graphs. Why did I do so? Because I'm supposed to determine the kind of acceleration from the graph. Generally, you would determine acceleration from a velocity time graph because acceleration is the slope. It is the slope of a velocity time graph. Remember, in this formula here, for acceleration, A is equals to V minus U over T. So if I was to draw a velocity time graph, velocity here versus time here, you would see that the slope here, if I was to do something like this, then I could take the slope of this graph. Let's just say I took the slope at this point by doing this as we normally do, and I'll take some dy over dx, okay, change in y over change in x. That will be the slope, right? We calculate this in mathematics. Well, what is my change in y? My change in y is my change in velocity, right? So which is sum v2 minus v1. And what is my change in x? My change in x is a change in time because this is the time axis, right? Maybe some t2 minus t1. My change in y was some change in velocity, right? v2 minus v1 because y is along the y represents the velocity axis. So you can see that my slope here, this is a slope. So my slope from this velocity time graph is velocity divided by time. But velocity divided by time is the same as acceleration from the formula of acceleration. So a velocity time graph has acceleration for its slope. So we can determine the kind of acceleration by looking at the slope of the graph. So in the first graph here, we have a constant slope. It means that if we were to take the slope of that graph at any point in the first graph, if I took the slope from here to here, I would have the same slope. If I took the slope at any 2 points here, the slope is constant. If I took the slope by using this other triangle, this one here, I would have the same slope. So basically, the acceleration is changing or is increasing at a constant rate also. The slope is the same. So this first graph represents uniformly accelerated motion. What about the second graph? Well, the second graph, as we can see, this is the second graph here. It still represents a constant slope, but in this case, the slope is decreasing, the slope is falling. You can see that velocity is reducing as time is increasing. Each time along the velocity axis, the value is dropping onto this point. And so this is still some kind of acceleration, but this is negative acceleration. So we call this deceleration. So here we have uniform deceleration. So you cannot consider this the answer because they ask for uniform accelerated motion or uniform acceleration. Now here, this other graph C here, graph C is a curve. You can see that graph C is a curve that bends upwards. So the velocity is increasing. Remember, I said all these could become velocity time graphs. All of these could be seen as velocity time graphs because they've asked us to determine the acceleration. So you can determine the acceleration from a velocity time graph because it is the slope of a velocity time graph. But here you see the curve rising upwards. Because the curve is rising upwards, it is not a straight line. The velocity is increasing, yes, no doubt, but it is increasing not at a constant rate. So the slope keeps changing. If you look at this graph here, if I was to draw a graph like this, if I was to draw a graph that looks like what you see in the question, the slope of that graph at this point is not the same slope here. You will agree with me that the graph is steeper at this point here compared to this point. So you can say the slope of the graph is changing. So even though the velocity is rising quite right, but the slope is changing. Remember, we said that for uniformly accelerated motion, the slope must be constant. So this cannot be the answer. Here too, graph D, we have a curve that is dropping. It drops steeply. The curve drops steeply here and then levels off in this area. So when the curve drops like that and levels off, the velocity is decreasing rapidly. The velocity is decreasing rapidly, but you can see that the slope is not the same all through. The slope at this point here is not the same the slope at this point. It tells us that the acceleration is changing. So for uniformly accelerated motion, recall this, acceleration does not change, A is the same, or the slope of the graph should be the same all through. So this is the correct answer.